number of analysts is 7 and the total number of fieldwork supervisors is 17. The question needs the equal number of analysts and fieldwork supervisors selected from Team A and B. So we need 1 analyst and 2 fieldwork supervisors from Company A and B. The total number of ways of selecting 2 analysts and 4 fieldwork supervisors is 7C2 times 17C4. And we know there are 3 analysts and 8 fieldwork supervisors from Company A, so the total number of ways of selecting 1 analyst and 2 supervisors from Company A is 3C1 times 8C2. In the same way, we can calculate the total number of ways of selecting 1 analyst and 2 supervisors from Company B is 4C1 times 9C2. So the answer of this question should be 3C1 times 8C2 times 4C1 times 9C2 over 7C2 times 17C4. It's 0.2420.
For question B1, is asking the probability of the van following a particular route. Since the security van needs to visit the 5 firms in turn every day but with different routes, therefore the number of particular routes is the 5 factorial, which is 120. And since it is asking the probability of the van following a particular route in any specific occasion, the answer of B1 is 1 over 120.
For part B2, the question is what is the probability of the van following a different route on each of the 4 consecutive weeks? From B1, we know that there are 120 routes for the van driver to choose. First of all, on the first week, the van driver can choose any of these 120 routes. So the probability is 120 over 120. Then for the second week, the van driver cannot choose the routes that he chose in the first week. So the probability is 119 over 120. Similarly, for the third week, the van driver cannot choose the 2 routes that he chose in the last 2 weeks. So the probability is 118 over 120. Similarly, we can know that the probability for the 4th week is 117 over 120. By multiplying all the probabilities together, we can get the answer of 0.9508.
Hello, I'm Dixon, and for part B3, the question will be what is the probability of 2 particular firms A and B being visited consecutively. So first of all, the question said that the company have to go through A and B company, which means have to go through A and then go through B, or have to go through B and go with A. They are linked together, therefore it's 2 to the factorial. And for other 3 companies, C, D, E, they can be mixed up around after that. Therefore, the total will be 4 parties. First is A, B, and then another 3 one will be C, D, and E. That's why they will be 4th of the factorial. And the question has said that the car of the company can choose different directions every day. So that with 5 companies, the denominator will be 5 to the factorial. And after doing the calculation, we'll have 0.4 as the answer.
So this is the group 2 and I will present you the question 2b. So calculate the probability that a randomly selected respondent prefers visiting the historical museum or prefer visiting the place. So we need to calculate probability of A union B, which is probability of A plus probability of B minus probability of A inter B. So let A be the event selected respondent prefers visiting the historical museum. Then we will note B, the event selected respondent prefers visiting the place. finally, probability of A inter B is the event selected respondent prefers visiting both the palace and the historical museum. So, probability of A union B. First of all, probability of A is 65% of respondents prefer visiting the historical museum. Then probability of B, we see over there 80% of respondents prefers visiting the palace. And finally, we need to subtract probability of A inter B. We know that 30% of the 80% who prefers visiting the palace also don't want to visit the historical museum. So this means that 70% of the 80% prefers to visit both the palace and the historical museum. That's why we need to subtract them. Over there we make 0.7 times 0.8, and the final result is of the probability is 0.89. Now I will present you the second part of the question. So the question is: a randomly selected respondent doesn't prefer visiting the historical museum. What is the probability that he or she doesn't prefer visiting the palace? So let B bar be the event the selected respondent doesn't prefer visiting the palace. A bar be the event the selected respondent doesn't prefer visiting the museum. So we will calculate the probability of B bar knowing A bar. This is the formula of the lectures. So first of all, we will try to find probability of A bar. We see just over there that probability of A bar is the whole rectangle except the yellow parts, which is 0.09 plus 0.56. So 1 minus 0.56 plus 0.09, and then probability of A bar inter B bar is the whole rectangle minus all the parts in pink. That's why it is 1 minus 0.09 plus 0.56 plus 0.24. The result of the probability is 11 on 35. So this is the third question. A randomly selected respondent prefers visiting the historical museum. What is the probability that he or she prefers visiting the palace? So we will calculate the probability of B knowing probability of A. There is the formula just over there, and one condition is probability of A need to be positive. So let A be the event selected respondent prefers visiting the historical museum. Then let B be the event selected respondent prefers visiting the place. Probability of A inter B is the event selected respondent prefers visiting both the palace and the historical museum. So probability of A is 0.65, it's given in the instruction. Then probability of A inter B is 0.56. We saw it in the first question. It comes from the fact that we know that inside the 80% who prefers visiting the palace, only 30% don't prefer visiting the museum, which means that the other 70% of the 80% prefers visiting both the palace and the museum. The proportion of P probability of A inter B is then 0.7 multiplied by 0.8, which leads to 0.56. Thus we find that probability of B knowing A is 0.56 on 0.65, which is 56 over 65. That the randomly selected respondent who only prefers visiting either historical museum or palace. So let C be the event of visiting either historical museum or palace. Probability of C is 1 minus probability of A inter B minus probability of A bar inter B bar. We have seen that probability of A inter B is 0.56 and probability of A bar inter B bar is 1 minus probability of A minus probability of B minus probability of A inter B, which is 0.11. And so we can calculate probability of C, which is 1 minus 0.56 minus 0.11, and the final result is 0.33.